In this video, we are going to discuss about basic op-amp circuits. In the last videos, we had seen the basics of op-amp, its input modes, ideal characteristics, and block diagram. So we know that op-amp is a very high gain amplifier. Whenever we want to use this op-amp as an amplifier, we need to control the gain of the amplifier. To control the gain of the op-amp, we need to go for negative feedback. That means we need to feed the fraction of the output signal back to the input. But to make the feedback negative, we must feed it back to the negative or inverting input terminal of the op-amp. And the advantages of using negative feedback is it reduces the gain and makes it controllable, and it increases the bandwidth, and also it reduces the distortion. Now, while analyzing the operation of op-amp circuits, two assumptions are made. First one is zero input current. As we know, the input resistance of an ideal op-amp is infinite. It means that no current is entering into the op-amp. That is, no current flows into an op-amp. So this makes the input current zero. Okay. So the second assumption is virtual ground. Virtual ground. Uh, we know that ideal op-amp has infinite gain, right? And the output voltage P naught is equal to gain into the difference between the two input voltages, that is A into V2 minus V1. Here A is gain. So V2 minus V1 is equal to V naught by A. If gain is infinite, if A is infinite, then V2 minus V1 is equal to 0, right? V2 minus V1 equal to 0, or V2 is equal to V1. This means that the input terminals of an op-amp are always at the same potential. Thus, if one terminal is grounded, the other one can be treated to be virtually grounded. The term virtual means that two terminals are not actually short circuited, but they are virtually short circuited. See, whatever the voltage appears at the one terminal, exact same voltage appears at the another terminal. So this is about the virtual ground. Okay, so now let us discuss about inverting operational amplifier. So inverting amplifier. An amplifier which produces a phase shift of 180-degree between input and output is called inverting amplifier. So this figure shows an inverting amplifier using op-amp. So in this case, we are applying input to the inverting input terminal. Okay, and input is applied through resistor R1, and we are providing negative feedback from output to the input terminal through the resistor RF. See, whenever op-amp is used in this configuration, then this configuration is known as inverting op-amp configuration. So now let us find out the relation between the output and the input voltages, and let us see how we can control uh, the gain of the op-amp using this feedback resistor RF and the resistor R1. So now let us find out the relation between output and input in terms of the feedback resistor RF and R1. See here, from the circuit, potential at node B, potential at node B, that is VB is equal to 0. VB is equal to 0. Now, from the concept of virtual ground, the two input terminals are at the same potential. That means uh, potential at node A is equal to potential at node B, that is VB. Okay, so VA is equal to VB is equal to 0. So now from the circuit, what is I1? I1 is equal to V in minus VA divided by the resistor R1, which is equal to V in minus 0, because VA is equal to 0. So V in minus 0 divided by R1. So I1 is equal to V in by R1. And IF, IF is equal to VA minus V naught divided by the resistor RF. So it is VA minus V naught by RF is equal to, again VA is equal to 0, right? 0 minus V naught by RF. So therefore IF is equal to minus V naught by RF. And we know that op-amp input current is 0. Therefore, I1, the current I1 passes through the resistor RF as current IF. So that means I1 is equal to IF. So I1 is equal to IF. So now I1 is equal to V in by R1. V in by R1 is equal to IF is equal to minus V naught by RF. So V in by R1 is equal to minus V naught by RF. So therefore V naught is equal to minus RF by R1 into V. So here the factor RF by R1 is gain of the amplifier. Okay, so this is the relation between the input and output voltages. Now the figure shows the input and output waveforms of an inverting amplifier. See, there is a phase shift of 180-degree between input and output. Okay, so this is about inverting amplifier. So now let us discuss non-inverting amplifier. An amplifier which amplifies the input without producing any phase shift between input and output is called non-inverting amplifier. So this figure shows a non-inverting amplifier using operational amplifier. So here in this case, we are applying the input to the non-inverting input terminal. Now, let us find uh, let us find out the relation between the output and the input in terms of feedback resistor RF and R1. See now from the circuit, potential at node B is equal to V in. right? VA is equal to V in. Sorry, VB is equal to V in. Now, from the concept of virtual ground, the input terminals are at the same potential. Therefore, VA is equal to potential at node A is equal to potential at node B. That is equal to V. So here VA is equal to VB is equal to V. Right. So now from the circuit, I1, what is I1? I1 is equal to VA minus 0 divided by R1. Therefore, I1 is equal to V in by R1. And IF is equal to V0 minus VA divided by resistor RF. And it is equal to V0 minus V in, because VA is equal to V in, right? So V0 minus V in divided by RF is equal to the current IF. So now we know that op-amp input current is 0. So therefore, current I1 is equal to IF. Okay. So I1, sorry, here IF passes through resistor R1 as I1. Okay. So now we know that I1 is equal to V in by R1 and IF is equal to V0 minus V in by RF. Okay. Substitute these two terms in this expression. So here V in by R1 is equal to, split this term, so V0 by RF minus V in by RF, which is equal to sorry, here V0, what is V0 by RF? V0 by RF is equal to V in by R1 plus V in by RF. So in this terms, V in is common. So V0 by RF becomes 1 by RF plus 1 by, sorry, 1 by R1 plus 1 by RF into V in. So therefore V0, what is V0? V0 is equal to RF into R1 plus RF divided by R1 RF into V in. Or V0 is equal to R1 plus RF divided by R1 into V in, or it is equal to 1 plus RF by R1 into V in. Okay. Output voltage V0 is equal to 1 plus RF by R1 into the input voltage V in. So here 1 plus, the term 1 plus RF by R1 is called the gain of the amplifier. So now input and output waveforms of a non-inverting amplifier is as shown. See here, there is no phase shift between the input and output voltage. Okay, so both are in phase. So now